Hello students, we are discussing calorimetry. The principle of calorimetry discuss heat loss equal to heat gain. How to use this? Let me show some question. All about using this principle. Right. A, B, C are three liquids. Right. A, B, C are three liquids, respectively maintained at temperatures. 60 degrees C, 50 degrees C and 45 degrees C. A, B, C are three liquids respectively maintained at temperature 60 degrees C, 50 degrees C and 45 degrees C. I am writing one question based on the idea of calorimetry. Right. If 4 gram of A is mixed with 6 gram of B, if 4 gram of A is mixed with 6 gram of B, the temperature of the mixture becomes 58 degrees C. Temperature of the mixture becomes 58 degrees C. When equal amounts of B and C are mixed, temperature of the mixture becomes 52 degrees C. Temperature of the mixture becomes 52 degrees C. When equal amounts of B and C are mixed, temperature of the mixture becomes 52 degrees C. Find the temperature of the mixture if 5 gram of A, 8 gram of B and 10 gram of C are mixed. Find temperature of the mixture if 5 gram of A, 8 gram of B and 10 gram of C are mixed. So this is the question what we should solve. Information given that three liquids present, different liquids, A, B, C different liquids, their temperatures are 60, 50 and 45. We have to get the temperature of this mixture. This is the question. What is this temperature to be measured? Look at what to do. When you are looking at A and B at lower temperature, A is at higher temperature, so heat lost by A should be equal to heat gain by B. A at 60 degree, final temperature becomes 58 degree. Formula for heat gain or loss is MS into delta T. Mass is 4 gram. Specific heat of A is not known. It is losing from 60 to 58. Heat gain by B by the same formula 6 gram. Specific heat for B, it is gaining to 58 from 50, so it is 58 minus 50. Be careful. Loss meaning initially getter, finally less, so minus. Initial minus final. Gain meaning finally getter, so final minus initial. So we get a link between SA and SB by this. So here we get a link between SA and SB. Simple calculation: 4 into SA into 2 equal to 6 into SB into 8. So SA equal to 6 SB, I think. So one link between SA and SB comes out by the information that when A and B are mixed, temperature of the mixture is 58 degree. Then we get equal amounts of B and C mixed. Now B is at higher temperature, so heat lost by B should be equal to heat gain by C. Equal amount, same constant m gram. M of SB into, it is 52, so 50, this is wrong. When B and C are mixed, temperature of the mixture should be between B and C. I wrongly wrote it at 52, sorry, it should not be 52, it should be lying between these two, say 48. To correct the question, in the sentence I wrote it wrongly. When you mix B and C, temperature should be lying between them. I wrongly wrote that 52, that should be 48. So please correct the question. When equal amounts of B and C are mixed, temperature of the mixer becomes 48 degrees C. I wrongly wrote it at 52. Not possible. When you mix, temperature should be lying in between. So B is losing from 50 to 48. So 50 minus 48 because B is at higher temperature. C originally at 45, finally 48. So M into SC into 48 minus 45. So here also you will get length. M goes cancel. SB into 2 equal to 3 SC. So here what is SA and SB, there is a link. Here what is SB and SC, there is a link. So these two link is very important from the information. Written when A and B are mixed, temperature of the mixer is 58, and when equal amounts of B and C are mixed, I wrongly wrote it at 52, that should be 48. When equal amounts of B and C are mixed, temperature of the mixer is 48. We have to find the result when A, B, C are mixed. So what is SC? Let me find from here, from this relation. SC equal to 2SB by 3. This is our SC. So we know SC in terms of SB, we know SA also in terms of SB. So first two part is over. Now let me go for the third part. These two relations important. When you mix A, B and C, I'm sure A is at higher temperature, definitely heat loss by A. And C is at lower temperature, definitely heat gain by C. But I am not sure what is happening to B. B is losing the heat or gaining the heat, no idea. So I am writing heat loss by B. It may be wrong, but automatically you will get correct answer, just wait. I am writing heat loss by A. Before that, you have to assume let the final temperature of mixer BP. So I am writing heat loss by A, written 5 gram of A, 5 into SA into, it is cooling from 60 to T. T is not known to be measured. Heat loss by B. Meaning we are assuming that temperature is less than 50, greater than 45. Heat loss by B I am writing, it is 8 into SB into 50 minus T. Heat gain by C I am writing, C is 10 gram. So 10 into SC into, finally T initially 45, so T minus 45. As C is gaining, it is always final minus initial. They are losing, so initial minus final. Look at my writing. I assume that final temperature is less than 50, so B is losing. By chance B is not losing, B is gaining, meaning final temperature is more than 50, then gain should be written here. If you write the gain here, it should be like this: 8 into SB into T minus 50. So automatically when you write this term here, comes with a minus sign. So automatically 50 minus T becomes T minus 50. So mathematically 100% correct if you are writing the first and the last property. Surely heat loss by A, surely heat gain by C. What is happening to B? No idea. Assume heat loss or heat gain. Anyone gives you correct answer. If you write loss, it is 50 minus T. If you are not interested in writing in loss, if you are writing in gain, it should be T minus 50. 50 minus T here or T minus 50 here, mechanically 100% same. So there should not be one problem with what is happening to the middle one. No problem. Just consider extreme 2 temperature correctly. What is SA? Let me write 5 into SA is 6 SB into 60 minus T plus 8 into SB 50 minus T. 10. What is SC written there? 3SB, sorry, 2SB. 2SB by 3, this is our SC, T minus 45. So SB goes cancelled from all, by solving T comes out. So this is the way how to handle if you are mixing more than two objects. Yeah? Just consider the highest temperature and lowest temperature properly as heat loss and heat gain by them respectively. In between whatever temperature, whether you write in loss or you are writing in gain, anyway you are going to get the correct answer. This term, if you write here, it is gain. If you write gain, it is T minus 50. So 50 minus T here, in the other side, minus of 50 minus T meaning T minus 50. So automatically correct. Just complete the calculation to get temperature T. But be careful, whatever answer should be lying between 60 and 45. Because you are mixing temperature between 60 and 45, result should be lying in between. Complete the calculation. So it's a nice concept learned. I'm sure you are quite capable of completing the calculation from your side, everything done by me. First two sentences, whatever given, from that we have to find the relation between their specific heat. And once the relation between specific heat is known, the final situation, whatever available, you have to use a mathematical equation. This is one type of question. One other type of question also possible, right? Find the result of mixing. Right, next question. Find the result of mixing. Find the result of mixing 80 gram of water. Find the result of mixing 80 gram of water at 60 degrees C with 40 gram of ice at minus 20 degrees C. I am repeating it. Find the result of mixing 40 gram of water at 60 degrees C with 40 gram of ice at minus 20 degrees C. You have to mix ice and water. Before you conclude what is going to happen, one rough set key is very important. Obviously, heat lost by water and heat gained by ice. Let me write heat lost by water. Water from 60 degree can cool to 0 degrees C. Just wait. 80 into specific heat of water is 1. It is cooling from 60 to 0. Formula is ms delta T. Heat gained by ice from minus 20 can be heated to 0. So 40 into 0.5 into 20. It is heated to 0. I am sure this part is greater. Because 80 into 60 is greater than 40 into 20. So we can think of melting ice. If you want to melt the whole piece of ice, first of all, let me simplify this one. Just rough idea. 8 into 6. If you write this one, it is so this heat is much greater. If it cools to 0 degrees C, let me think of melting. To melt 1 gram of ice, we need 80 calories. So here 40 gram I want to melt. 40 into 80, what is that? Still this sum is less. So while ice is heated to 0 degrees C, 400 calories utilized. Then the ice is melted, another 3200 calories utilized. Their sum is less than this one. So sure, water will cool not to 0 degrees C but to T degrees C. Because this heat is greater, it is not going to cool to 0. Cool to some T degrees C. Right. This is the second process. You have to identify what is going to happen. Right. In this case, let the temperature of water, cools to some T degrees C. So I am writing heat loss equal to heat gain. This is only the second part. Heat loss is 80 into 1 into cooling from 60 to some T degree. Because if it is cooling to 0 degree, heat loss is greater than the heat required. Heat gain, first of all, it will be heated to 0 degree C. Plus, it is to be melted. After melting, the temperature of this ice piece should be heated to T degree, because we say resultant temperature is T. So it is 40. After melting, it becomes 1. We want to heat it to T degree from 0. Let me do the calculation. Remaining is only calculation. I am sure you will get the answer. Just let me show the idea. It is just multiply. This term is 400, this term is 3200, this is 40T. Remaining is only calculation. Let me complete the calculation here. It is 4800 minus these two, their sum is 3600. Right side 80 and 40, 120T. So 1200 equal to 120T. So T equal to 10 degrees C. So it will cool to 10 degrees C, not to 0 degrees C. So what is the result? Water will cool to 0 degree and ice will be heated to 0 degree. Water will cool to 10 degree and ice will be heated to 10 degree. First complete the calculation, then what to write in the answer, let me explain. First of all, a checking process to identify what may happen. Accordingly, we are doing calculation, right? In this case, the temperature of the mixer will be only 10 degree. Temperature of the mixer will be 10 degrees C. In this case, temperature of the mixer will be 10 degrees C, and the mixer carries only water because all ice gets converted to water, and the mixer carries only water of total mass 120 gram, 80 plus 40. The question may be different if the checking gives us different answers. Just write the question once more with a slight modification. With a slight modification, let me write the question again. Right. If in the above problem, mass of water is only 50 gram. If in the above problem, mass of water is only 50 gram, find the same. If in the above problem, mass of water is only 50 gram, find the same. So previously we solved with 80 gram of water, now mass of water is only 50 gram. Just I want to show the difference. Ice, if heated to 0 degrees C and melted, amount of heat required is this. But this water, as it is 50 gram, if you allow it to cool to 0 degrees C, amount of heat coming out is this one. So I am sure this is better. This is total 3600, this is better. So one thing here, even if water cools to 0 degrees C, it cannot melt the whole piece of ice, because for melting whole piece of ice we need more heat. So idea will be different now, right? First of all, this second process, my advice is note down the second process. Then write, in this case, the whole piece of ice will not melt. If you find my talking or my writing, first you pause the video, complete your calculation, then come back. But you must write it. This is the most essential thing. Right? In this case, whole piece of ice not going to melt. Let m gram of ice melts. Let m gram of ice melts. So I am writing heat loss equal to heat gain. heat loss is 50 into 1, it is cooling to 0 degree. Heat gain, first part will be there, 40 into 0.5 into 20. The whole piece of ice is heated to 0 degree C. After that, whole piece not going to melt. So 40 gram not going to melt. Instead of that, some m gram melts. Let me complete the calculation. It is 3000. This multiplication gives us 400 m into 80. So it is, after calculation, m into 80 equal to 3000 minus 400 is 2600. 1 0 goes cancel. M equal to 260 by 8. It is, let me divide. I think calculation done correctly. So 32.5 gram of ice melts and still remaining as ice. So right, in this case, has note down this mathematics, then you should write. In this case, temperature of the mixer is 0. In this case, temperature of the mixer is 0. Amount of ice melted is 32.5 gram. So amount of ice melted is 32.5 grams. So amount of water present in the mixer is, amount of water present in the mixer is already 50 plus 32.5. Amount of water present in the mixer is 82.5 gram. And mass of ice present in the mixer is, and mass of ice present in the mixer is 7.5 gram. Why? Out of that 40 gram, 32.5 gram melted. So 7.5 gram still ice, is still remaining as ice. So be careful. Observation gives the clue what to do. Just go for a rough checking process by heat loss and heat gain. Estimate what is the possibility and then try to solve. Note it down. It is all about good observation. Heat loss equal to heat gain is the principle. There should not be any difficulty in doing calculation, but before you do calculation, my advice is always look at what is the possibility. One last question from my side. Right. Find the result of mixing. Find the result of mixing 20 gram of ice at minus 10 degrees C with 20 gram of ice at minus 10 degrees C with 5 gram of vapor at 106 degrees C. 5 gram of vapor at 106 degrees C. Now we are mixing ice and vapor. Before you do any calculation, you should always identify the possibility. I am looking at heat loss and heat gain. This ice, if you heat to 0 degrees C, then 20 into 0.5 into 10. If you want to melt it, amount of heat required is 20 into 80. Let me do rough calculation. It is 100. Let me see the heat loss. Vapor 5 gram, specific heat of vapor is 0.5. If it is cooling from 106 to 100, that is 5 into 0.5 into 6. So 3 I think. It is 30 into 0.5. 15. So this part gives us only 15 calories. When this vapor gets converted to water, look at, when water gets converted to vapor, you have to supply heat. When vapor gets converted to water, you have to withdraw heat from it. So heat lost by vapor when it gets converted to water is 5 into 540. I think 2700. So when this vapor first gets cooled to 100 degrees C, it is capable of releasing only 15 grams. When that vapor gets converted to water, it is 2700, but still at 100 degrees C. And my ice at 0 degrees C, because first of all heated to 0 degrees C and melting. Melting meaning still at 0 degrees C. This heat is gathered. This is less. So you can think of increasing the temperature further. If you increase the temperature further, then amount of heat required to increase temperature up to 100 is ms into delta T from 0 up to 100. So another 2000 calorie coming. This is not available because it is only 2700. So one thing sure, it is not going to get temperature exactly 100. It will be somewhere in between. But all vapor will be converted to water, all ice also converted to water. Right. Up to this one not possible because this amount of heat is not there. Right. In this case, first is observation, then conclusion. Right. In this case, temperature of the mixer will be T between 0 to 100. In this case, temperature of the mixer will be T between 0 to 100. So let me write heat loss equal to heat gain. Heat loss I am writing 5 into 0.5 into 106 minus 100 plus 5 into 540. It is 100 degrees C now, it is cooling, so 5 into 1 from 100 it is cooling to T. So plus 5 into 100 minus T. Heat gain, first part is this 20 into 0.5 into 10 plus 20 into 80 plus 20 into 1. It is increasing temperature from 0 up to T degree. So it is 5 into 0.5 into 6 plus 5 into 540 plus 500 minus 5T equal to this one 100 plus this is 1600 plus 2T. Let me do the calculation. This part is 15, this part is 2700 plus 500 minus 100 minus 1600 equal to 70. So let me write all this together. It is 2700 plus 500 is 3215 minus 1700. So finally 7T equal to 1515. So T equal to 1515 by T. So temperature is, if you divide 2 1 I think 21 point. Am I doing some calculation mistake? Yeah, calculation mistake. This is 20, sorry. Because mass is 20, I wrote 2. 20 into 5, so 2070, sorry. It is 2070. I wrote wrongly 2, it was 20. So it is 2070. 25, please, sorry. So let me pack it. It is 5. I think 61 degrees. Complete the calculation from your side. If any mistake you notice, if only calculation mistake, it can be corrected. I wrote this one as M as delta T formula. Mass of ice was 20. When converted to water, then also mass is 20. Specificity is 1. We are heating it from 0 to T degree. So T minus 0. This is 20. From here 1 5. So 5 and 20 25. So I wrongly wrote that one wrongly as 7. So complete the calculation. It is not 2070. It is 2050. So final temperature is 61 degrees C of the mixer. So in the mixer, no vapor present, no ice present, only water, because at 61 degrees C, ice and vapor not possible, only water possible. So this is the way how to handle. My advice is look at the shaking process first. Once the shaking process clear, you are clear with the idea of what may happen. Remaining part of the calculation is simple. So this is how we should use calorimetry. My advice is look at the solved questions of SC Burma. You will get some idea. Then finally, it is up to you how you utilize your thinking. Thank you. This part is over.